Welcome back to the deep dive. So, you know that frustration, right? You've got a TV or a projector on one side of the room and your source is on the other, and that HDMI cable is just, it's never long enough.
It's a classic problem. 50
What?
feet is pretty much the hard limit for a reliable signal over copper.
Exactly. But today, we're looking at the documentation for a little box that claims to fix this by basically ignoring the HDMI cable limit altogether.
We are. It's the NTI ST-IPHD-LCAU.
Rolls right off the tongue.
Yeah, not so much. It's the low-cost HDMI over Gigabit IP network range extender, which, is a lot clearer. It's really a bridge between the AV world and the IT world.
So our mission today is to dig into how this thing actually works and maybe more importantly, figure out where the catches are. The big promise is 1080p video and audio up to 330 feet.
100 meters. And it does it over a single standard CAT5E or SIT6 cable.
Which is the magic part. So
Yeah.
it's not just boosting the signal, is it?
No, it's much smarter than that. It's actually converting the video into data packets. It takes your HDMI feed, compresses it, and sends it out over a standard computer network.
Okay, compression is a word that always gets my attention. The sources mention it uses MJPEG. That's motion JPEG, right?
That's the one. It essentially turns every single frame of the video into a JPEG image before sending it. Raw HDMI is just way too much data for a standard gigabit network to handle.
So my next question is always going to be about lag. If you compress it, send it, and decompress it, there has to be a delay.
There is. And they're upfront about it. The spec sheet says the encoding delay is about 33 milliseconds if you're running at 30 frames per second.
33 milliseconds. Okay,
Yeah.
That's basically one frame of video.
Exactly. You would absolutely feel it if you were trying to play a fast-paced video game, but for watching a movie.
You'd never notice. Okay,
Yeah.
So let's talk about the setup. The manual shows a simple one-to-one connection, but the really interesting part seems to be the one-to-many setup.
Right. The point-to-many. That's the perfect digital signage scenario. Think of a restaurant or a sports bar with TVs all over the place showing the same game.
Instead of a huge, crazy, expensive HDMI splitter, you just put one of these transmitter boxes on the network.
And then a little receiver box at every single TV.
But there's a huge warning label here in the documentation. It says if you have more than one transmitter, you can't just plug this into any old network switch you have lying around.
No, you absolutely can't. You need what's called a managed switch.
And it needs two specific features, VLAN and IGMP. Can you break those down real quick?
Sure. A VLAN is a virtual local area network.
Yeah.
Think of it like creating a private high-speed lane on the highway just for your video traffic so it doesn't get slowed down by, emails and other junk.
Got it. And IGMP.
That's maybe even more important. It stands for Internet Group Management Protocol. Without it, the switch would just blast the video stream out to every single device on your network all the time.
Which would crash everything.
Instantly. IGMP tells the switch to be smart and only send the video to the specific receivers that are actually asking for it.
So this isn't quite plug and play for big setups. You need some networking knowledge.
You do, but if you have it, the docs say you can even cascade these managed switches. You can link up to 3 of them together to push the signal even further.
How far?
Theoretically, almost 1,000 feet.
That's a long way.
Yeah.
But okay, we have to talk about the trade-offs. We know there's a frame of latency. What about the picture quality itself?
This is the other big warning in the manual. Because of that MJPEG compression, it specifically says that high-resolution text from a PC can appear noticeably fuzzy.
Ah, so it's optimized for moving pictures, where your brain kind of fills in the gaps.
Exactly. It's fantastic for video, but if you're trying to display a detailed Excel spreadsheet in a boardroom, your numbers might look a little soft.
Right. And the other big recommendation they make is network isolation.
Yeah, they strongly suggest you put all of this on its own dedicated network. Don't mix your high bandwidth video traffic with your critical office phones and computers. It's just asking for trouble.
So when you add it all up, it's a super practical tool. It's solving a real infrastructure problem, but you have to play by these very specific IT rules.
It's the perfect example of AV becoming IT. We're not just pulling cables anymore. We're managing data packets.
Which I think leaves us with a really interesting final thought for you to chew on. As devices like this become more common and video just becomes another type of data on our networks, are we watching the end of the dedicated video cable? Is the future just a single Ethernet port for everything?
The convergence is undeniable. The line between a computer network and a video distribution network is, well, it's pretty much already gone.
Something to ponder next time you're stuck behind your TV with a cable that's 2 inches too short. Thanks for listening to this deep dive.